All right. Hi, guys. Good evening. This is Project One. My group members were myself, Esme, Ben, Alyssa, and Juan. Moving into the introduction, this project was all about particle equilibrium. In Chapter 3, it talked about particle equilibrium and why it was important to the statics. It is important to know that this project is specifically about an object or particle that is not moving or rotating, and it requires that all the sum of forces and moments acting on the particle to be zero. And so for that project, for the introduction, we had this diagram made by Ben, handwritten, hand drawn, and we decided to choose a tire swing. The tire swing, as you can tell, is not moving, and the sum of forces is equal to zero. And we move on to the assumptions.
All right, some assumptions we made in reference to our project was that from the collection of cables at the top, which we defined as point A, to the center of mass of the tire, you were using 8 feet, and we used a tire that was 40 inches with a radius of 20 inches and a mass of 108 pounds. And we also had chains that had a loading working weight of 375 pounds, which ended up not being needed. Next, we have our free body diagram, which shows that the weight of the tire is being supported going up in the positive Z direction, while the tension chain are going down in the opposite direction from point A.
The equation that we used in this project were F equals 0, Fx equals 0, Fy equals 0, and Fz equals 0, which will be shown during our calculation portion of this presentation.
For our calculations, we found the position vectors for A, B, and C. The position vector for A to B was 0.204 I hat minus 0.979 K hat. I then found the tension of A to B by using the sum of forces and solving for FAB, which was 36.7 pounds times feet.
Okay, and for me, I was responsible for the A to C and portion to the origin. We use the Cartesian vectors and the displacement. My calculations was negative 0.1019 I hat plus 0.1762 J hat and minus 0.9789 K hat. And like Alyssa said, we then found the angle to be 11.77, and then we used that to check our work, and then as well found the sum of forces.
Alrighty, and similarly, I was responsible for the next chain, which was A to D, where I took the position vector and divided it by its magnitude to get a unit vector. My unit vector was negative 0.10198 I hat minus 0.1762 J hat minus 0.979 K hat. And using those values in our sum of our X, Y, and Z values, we noticed that for Y, that FAD was equal to FAC. And when using our Z values equal to 0, we were able to calculate FAD to come with a conclusion that 36.772 pounds per feet were the tension in each chain.
So my part, I was in charge of solving for the shortcut, which led me to first solve for the inverse of tangent, which gave me 11.77 degrees, which as is shown during my calculations, tension equals FAB, FAC, and FAD, which led me to plug in 108 minus 3t cosine 11.77, which gave me 36.8 pounds.
We concluded the state of particle equilibrium has been maintained by the sum of forces equaling to 0 of the symmetrical chains distributed by a third of the tire's weight within the system. Thank you.